In this video, I'd like to introduce the concepts of position, displacement, distance, and the origin. But before I get into any of those terms, I should first indicate that all of our measurements are made relative to some frame of reference. We'll be making most of our measurements with respect to the Earth, or the ground. And when we make a measurement, if we talk about, for example, a vector, we not only describe like how far it's gone, for example, but we like to also to indicate what direction, like north, east, south, west, up, or down. But in physics, what we like to do often is to set a coordinate axis down. In this case, you can see there's an x-axis shown here, and this is the positive x-axis going to the right, and the negative x-axis going to the left. So when we talk about the position of an object, the place where that object is, we would like to make a measurement with respect to this coordinate system. Imagine a grid that is laid down on the ground to make that measurement. So the position of this object in one-dimensional motion is whatever its x value is on that coordinate system. And if the object moves, say starting here at an initial position of 5, and then it moves all the way to the flag, at -4, and then it moves to 2 right here to this new location, which I'm going to call x sub 2, then we can talk about the distance that the car actually traveled and also the displacement, which is the change in position from the final position to the initial position. You can think of these as both vectors here. So let's go to this question and tell me what you think is the displacement of the car, which is the change in position, and then also what is the distance that the car traveled. Let's start off with the displacement. That's delta x, which is the change in position, and that's the final position, which is at 2, minus the initial position, which is at 0. So we're going to take these two positions and we're going to subtract. So relative to this 0 spot, by the way, this is called the origin, the object was at a final spot of 2 meters, and it has an initial position over here, x sub 0, of 5 meters. So the displacement of the object is -3 meters. And this is relative to the positive x-axis. So in reality, because we have a negative in here, really the car has moved 3 meters or 3 whatever it is. I guess we'll indicate this as in meters. This means that it's gone 3 meters to the left. So you could, I suppose, say positive 3 meters relative to the negative x-axis. It's up to you. What about the total distance that the car traveled? The total distance the car traveled, just so you know the difference between what is this compared to displacement, would be the actual length that it traveled. So it went from 5 all the way to -4, that would be like 9 units, and then it went from -4 all the way up to 2, that's 6 more units. So this would be just 15, say, meters if we were writing this in meters. Normally in this course, we're going to be only concentrating on the position and the displacement, and sometimes we'll talk about the distance, but in most of our formulas, everything is going to be described through position and displacement. Okay, now you can move on to the next video where we discuss the difference between speed and velocity.